There are more proofs as to how we get the formulas that we use. So let's not waste time and let's jump into it. What we have now is cosine of alpha minus beta is equal to cosine, cosine, sine, sine, but it doesn't keep the same sign. And everything goes, I dare say it, alphabetically. It goes alpha then beta, alpha then beta. You'll need that later. Just make a note of it. As my buddy says, alphabetically. I hate puns, but it seems to work. All right, so what we want to go solve for is we want to go get what's cosine of alpha plus beta. That's our next one. You're like, dude, just go look online. It's right there. You can go find it. Yeah, you can. But maybe understand what the hell you're doing. And that'll make everything like 1,000 times easier. And even maybe just watching you never understand it, it still makes you better. It's just strange how it works. It's like reading the book before going to class. That was something I learned late. So we need to turn this into some sort of subtraction, because that's all we got. We got a subtraction, that's a plus. We're like, well, let's see if we can't change it up. And we're going to use just a real simple concept. We're going to say cosine of alpha minus negative beta. Minus negative beta. What this is going to allow us to do is we now have the subtraction that we needed. Yeah, we got the subtraction like we needed from right there. But instead of putting in positive beta everywhere we see, we're going to put in negative beta. All right, so let's write down below. Cosine of alpha plus beta. And it still goes cosine, cosine, sine, sine. So it goes cosine of alpha, that's our first, times cosine of the second. Then that's negative beta. It's not positive beta this time. And then we say plus, and then we go sine of alpha. Alpha didn't change. And then we say sine of, and it's not positive beta, but negative beta. Right. Let me just pop those two in right there. And now we use the even and odd properties to be able to finish this thing. Cosine of negative beta is the same thing as cosine of positive beta. Cosine is an even function. Now sine of negative beta is actually equal to negative sine of positive beta. That's an odd function, so we're merely going to change this sign right here when we go to plug this in. So then we go minus sine of alpha, sine of positive beta. And it's because it's like that negative traveled out and went over here. Okay. So there it is. There is our cosine of alpha plus beta. Dope. We're going to use this. Most of what we use our sum and difference formulas is to build other things. We don't typically use a lot of sum and difference formulas in applications. But man, this is what builds everything. Once we have cosine of alpha minus beta, we then are able to build everything. Everything from this. It's going to build our double angles, our half angles, our reduction formulas. Oh, it's going to do it all. So there's our two. But there's also some sine ones. So, man, I suck sometimes. So, all right, here it comes. Oh, let's go find sine of alpha plus beta. Let's go get that one. We're going to have to turn this into cosine. We're going to need to turn this into cosine to be able to solve this. We do know that from prior sections that sine of an angle is equal to cosine of pi over 2 minus the angle. That's the complementary angle theory. So we're going to use this thought process, except we're not going to use alpha. We're not going to use theta. We're going to use alpha plus beta. So we can say that this is equal to cosine of pi over 2 minus that angle that's inside alpha plus beta. And if we take this negative and we distribute it in, we get pi over 2 minus alpha minus beta. And then here's the weird. Here's how we can break this thing up and use it. Let's look at where our parentheses are. We now have something separate, an angle minus another angle. We can now use cosine's difference formula, which goes cosine cosine plus sine sine, and we go first second. So it's going to be pi over 2 minus alpha times cosine of beta. Sine of pi over 2 minus alpha, sine of beta. Just popping those two things in. But cosine of, oh, do I need to change that to an alpha? That's just equal to, down here, cosine of pi over 2 minus alpha, that's equal to sine of alpha. That's the complementary angle theorem. It's cosine of beta. And then again here, we're going to be like, well, dude, sine of pi over 2, sine of pi over 2 minus an angle is just equal to cosine of that angle. So it appears to be that sine of alpha plus beta is indeed equal to sine alpha cosine beta plus cosine alpha sine beta. And it appears that sine keeps the same sign. And it goes alphabetically. And the way you chant this one, sine, cosine, cosine, sine. Cosine goes cosine, cosine, sine, sine. Sine goes sine, cosine, cosine, sine. And it's all alphabetically. I'm going to give you the next one. Not make you go through it. You'll have to see this nonsense. The only difference in form is you'll have a negative sign because sine keeps the same sign. And then now you're like, well, shoot, you said the others. Dang. Oh, we got to sit through 4 more of them? 4 more of these sets, not just these 4? Well, absolutely. Let's get into it. So, tangent of, oops, let's get a bigger of a font here. Just zoom in. So, tangent of alpha plus beta. Do you know what that's equal to? It's equal to sine of alpha plus beta over cosine of alpha plus beta. Yep, there it is. Found it for you. And do you know what tangent of alpha minus beta is equal to? Hang on. Hang on. I got you. Woo! We did it! We figured it out. Do you know what cosecant alpha minus beta is? It's 1 over sine of alpha minus beta. There's only sine and cosine. That's how you'd find cosecant. There's formulas for them. You can go look them up. Tangent has a formula as well. Tangent also has a formula. Can I even remember what this formula is? Hold on. I never even think about this tangent because I know sine and cosine. I would never fill my brain with this. So maybe I'll pause and come back and know. Yeah, there it was. So this is going to become tangent alpha plus tangent beta over 1 minus tan alpha tan beta. And tangent of alpha minus beta is tangent alpha minus tangent beta all over 1 plus tangent alpha tan beta. And I'm not kidding. I literally had to go look that up. I don't frickin' keep this stuff memorized. I know the proof, and I could do the proof for you if you like, but I'm going to leave that one out. Dude, it's everything sines and cosines. Like, there's your formulas. Neat. I think your book uses U's and V's. I use alphas and betas. But I'm going to continually set you up. Your problems when you go to take your exam for exam 2, I'm going to ask you stuff like this. I'm going to ask you about tangent of alphas and betas. But I'm going to already ask you about sines and cosines. You can shortcut this stuff and just be able to write it one over the other. I don't want you to use tangent sum formula. I don't want you to use tangent difference formula. But I'm going to ask you questions about it. And you're going to know because you're watching this dang video and you're listening. You're like, dude, don't do that. Just know sine and cosine. You get everything else for free. So we'll drop some hints throughout the other videos. And by the time you get to the end, you're going to see it. You will. You'll have this shit on lock. And go look at my old exams too. Keep pretty similar stuff. Okay. So there we go. We got our formulas. We don't really need to know anything about cosecant, secants, and cotangents. If you want to know their sum and difference formulas, go look it up online. I have no clue about those. But I sure as hell could solve them by flipping numbers over. All right, in the next, we'll actually start doing some solving. We'll see the games that we play with it. So your proofs are done for a bit.